So today our book talks about factorials and abstract rate problems. So first off, does anybody remember what factorial is talking about? Seeing a few hands shaking like maybe, maybe not. Not real sure here. What if I asked you, does anybody remember what this sort of notation means? What does it mean when we have an exclamation mark in there? Like, what does 7 factorial, 7 exclamation mark mean, Ronald? That's a good guess. We have a squiggle that means not. Emma?
It's like 12 kind of.
Well, I was doing 7 to make it not quite so long and involved to answer. What's 7 factorial? What's 7 exclamation mark? So we take that integer times each of the successively smaller integers until we get down to 1. So we're going to evaluate ones like this without a calculator. So what I recommend doing is picking out what is the biggest one in there, which is obviously the 12 factorial. So I'm going to start writing out 12 times 11 and so on. I'm going to look, if the biggest one was in the numerator, I'm going to look in the denominator for the next biggest thing. If I started with the biggest one in the denominator, I'd look for the next biggest one in the numerator. So the next biggest one is 7. So when I write out the 12 factorial, I'm not going to write it all the way. I'm going to write 12 times 11 times 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. So that all at once I can divide 7, 6, 5, 4, 3, 2, 1 and 7, 6, 5, 4, 3, 2, 1, and they cancel completely out. Just to save a little bit of writing. Are we good with that much? We've still got the 3 factorial, so we have to write out the other one. We can only cancel one of them ordinarily, not both of them. Then we just look for elementary school kind of problem. Are there some things that we can cancel? I have a 3 and a 2 in the denominator, so I could cancel the 3 with part of the 9 or with part of the 12, but not both. It only cancels one place. I'm going to choose 3 times 2 is 6. That goes into 12 2 times. Then I'm going to try to do some grouping that's not too hard to do without a calculator. So I think I can do 8 times 9 is 72 times 10 is 720. And I think I can do 2 times 11 is 22. And then I'm just going to do good old-fashioned long multiplication. 720 times 22, 0, 4, 14. And then I'm multiplying by 2 again, so just scoot everything over 1 spot to the left, add my rows, and this factorial becomes 15,840. Any questions with what the notation means? It's just being careful. Make sure you don't skip one of the numbers when you're writing it out. That's the most common mistake I see. All right, let's move on to something a little bit harder for today. Abstract rates. Abstract because instead of saying the car is going at 40 miles per hour, they're giving it to you with S. So variables are going to be in there. You've had all kinds of other abstract problems where you've ended up solving for a variable. Same kind of thing. We are, with these, going to need to use rate times time is distance. And I strongly recommend, with these kinds of problems, that you do a table, rate times time equals distance, the first situation and the second situation. We're going to start with the first column, and as soon as we have 2 things in it, we're going to stop reading the problem and use RT equals D to get the third thing in that column. Then we go back to the problem. So a car traveled at S feet per minute. Rate, time, or distance? That's a rate, so that's the first rate. It goes U feet. What's U? I have 2 things in that column, so I stop for the moment. I'm going to figure out T from RT equals D. So if I need T, it must be D over R. So if D is U and R is S, that means time must be U over S. Now I'm going to go back to my problem for case 2. Figure out R2, T2, and D2. So let's go back to the problem. And let's see. We want to know how fast the car should have gone, so we want to know the rate. So pick some variable that they aren't already using. They've got S and U, so I'm going to pick X for the one that I need to find. And then, are we going to go the same distance?
Yes.
So distance is still U. Now for the third one, we're going to think about it, of how do we adapt it from column 1, and we're also going to need R times T equals D to be true for case 2. Sometimes you'll be adapting 2 of these as you fill in column 2. For this one, they were 6 minutes late. They took too much time getting there. They need to get there in a shorter time. They needed to get there U over S minus 6. Now, one of the tricks on these is never leave that as a subtraction expression. Change it to one fraction, not 2 separate pieces. So common denominator, I could say that is U minus 6S over S. Now I need to figure out and make column 2 be true so that R2, T2 equals D2. So R2 is X, T2 is U minus 6S over S, and D2 is U. But I am supposed to solve for X, so this is why we want it in a fraction, so it's easy to see the reciprocal. You can't take S over U minus 1 over 6. That does not work. You've got to have just one fraction that you turn upside down. So we are going to multiply both sides of this by S over U minus 6S so that we end up with X equals S times U over U minus 6S. And then we just need to label that with units. This was how fast should the car have traveled, so that's a rate. And our units for rates are feet per minute. So we label that feet per minute. And that is the rate that we were looking for. Kind of weird, I know, but anybody with questions on that? Okay, let's do one more of these. So once again, we're going to have our 2 columns. Rate times time equals distance. Case 1, case 2. So first time around, C miles per hour. So C is the rate. D hours, time. We have 2 things in that column, so we finish that column by RT equals D. So that means D has to be C times D. Then we go back to the problem and start reading again to fill in column 2. So on the test run, it didn't go far enough. It needed to go a longer distance. So the distance we need for case 2 needs to be CD plus 47. We want to know how long it takes, so we're trying to find the time. I've used C and D, so I'll use X for what I'm trying to find. And we're going to increase the rate by 15. So instead of C, it's now C plus 15. But R2, T2 has to equal D2. That has to be true for the second column as well as the first. So R2 is C plus 15. P2 is the x that we're trying to find. The distance is CD plus 47. So if I want to isolate x, I just divide by the parentheses c plus 15. And x is CD plus 47 over c plus 15. Look back at the problem so we can label it. We were trying to find how long it would take. Our units for time are hours. And there is our solution on that. Does that make sense?